on another tutorial on the Julia programming language. Today we are starting to cover machine learning. Machine learning is very commonly used for various tasks. There are many different algorithms to complete certain tasks. And one particular group of machine learning tasks are classifications. So where we have certain inputs into a machine learning model, and the model returns a like a category of things, right? And we'll go into an example, but we're also going to do a machine learning example on such classification. We'll start with importing some libraries that we need. We use our datasets to get us a dataset that is particularly suited for our little fitting example here, and we're going to add scikit-learn. So it's doing all that. If you install this for the very first time, your output will look a little bit longer. I've done it before, so that's why it gets done very quickly. And now I'm doing the import. And you notice here that I do import the entire modules as well as certain functions in a module. I'm also importing this sk import handle here, which lets me to directly import a scikit-learn class directly from the Python scikit-learn. This is one way of porting over Python code. So that's a random forest classifier that I want to use. And now let's go ahead and bring up our data set. It's called Iris. It's a very commonly used data set to just demonstrate classification. So if you are familiar with machine learning, then you certainly have seen this example before, right? And so you see it's a very neatly organized data set. It's not very long. I think it's about 150 data records, and there is 4 input variables and 1 target category variable. The 4 input variables are geometric attributes for certain flowers, and then the target is the actual species of the flower. And in this data set, I believe there are 3 different species of flowers contained. So all these geometric measurements should contain all the information to make a prediction on what kind of flower are we looking at here. And now let's go ahead with the standard practice in machine learning. The first thing is we'll do a train test split. So what we'll do here is we call matrix on the iris data frame, which makes it into a matrix. So that's very similar to calling the dot values method on a pandas data frame. You now have a 2-dimensional array, and you also place in one of the parameters, which is test site, and we say test size, we were saying 30% of the data should be test data. And it returns me these 2 arrays. And so I'm just going to look at these, right? So the size of the training set has 5 columns, 105 records. The size of the test set, of course, has the same number of columns, and then roughly 30% of the total data, 45 records. Next thing we do is to also further then line what is actually input output. So we take the first 4 columns of train and test set, and that is going to be our X, our input. And we'll take the 5th column, and that is our output, the Y. And we have to cast it into a string here, otherwise our classifier will not accept it. So you see the actual type here in this data frame is a category, which is correct. It is category that we are predicting. However, the random forest classifier that we imported from scikit-learn, it doesn't quite know what a category is, so we have to cast it into a string, and so we do that. And now we have actually, it prints out the last thing. So we have here the names of these flowers all in a row. now I'm loading the random forest classifier. You can usually pass on further parameters such as how deep you want to have your decision trees, how many trees, how many features do you want to have, the sampling algorithm. There's many things you could modify, and it certainly makes sense to look at a few of those. Usually, though, my impression is that this works quite well out of the box for a lot of smaller problems. Of course, not for all, but if we just want to demonstrate how to run this model, we can just take it out of the box. And then we call the fit method. So fit here, and you see fit with an exclamation mark. That exclamation mark means it will actually modify the variable that we're passing in here, which is model. And so after we run fit, the model is then a different or has different properties, right? So it has actually been internally fit. And now we can call simply the predict method on it, or we can call predict model and inputs, right? So both actually work. So predict is actually the built-in method from the Python class, and predict now is actually the Julia function where it's predict model input, right? And so when I do the predict, we see it really predicts out these strings, the names of the flowers. And the way to now make an assessment of how good our model is to calculate its percentage of how often it was accurate, right? That is one measure. That is by far not the only measure, but just for this example, let's go to this exercise. So we're going to predict on this test set. This will give us an array of these basically these flower names, and we do an element-wise comparison to the target test set, right? And this will turn us an array that is 1 for each element where it really matches the prediction, and 0 where the prediction was false. So now if I take the sum of this array, it gets me in the end the number of correct predictions, and that I divide by the number of overall examples here. And so when I run this, it gives me here the percentage of accuracy, and it is 95.5%. This is pretty good. So by far, this is not the end of everything you could do here in machine learning. In this video, I wanted to give you an overview of what libraries you need to get started on machine learning in Julia. There's certainly a lot of things you could do. Confusion matrix, you follow best practices for machine learning. But just to give you an overview, I hope you find this video helpful, and I look forward to seeing you in future videos when we cover more examples of machine learning in Julia.